Let's talk about blockchain forks. We've done 2 of them right now. If time permits, we're going to do another one. And let's start to categorize them. So in an ideal world, this is our chain. Everything's linear, one block after another. We actually had something a lot like this when we were all just doing MD5, other than the occasional fork that came up because someone mined around the same time. Speaking of that, in the real world, it actually does look like this. Maybe these 2 miners both found a block around the same time. This is actually the exact example I talked through earlier. Neither one of these is inherently better at first, but then once this block gets mined, now the bottom chain is longer. And I never really told you guys, but this node is using the longest chain rule. That's its fork choice heuristic. So once we see this one, then we can say like, okay, even though neither of these is objectively better, we now know to reorg over here to the longest one, and we can kind of orphan this off, at least for now. And sometimes it actually even gets a little bit more chaotic, especially if we have a lot of people mining or a lot of mining power coming in all at once. And actually, it doesn't even have to just be POW. We learned from Andrew yesterday that this kind of thing can happen even in Babe. So like, for example, in Babe, if 2 validators output their VRF and they're both below the threshold, then they both author a block in this slot. Apparently that happened in this slot and this slot also. And the reason that it's just a little inconvenient here is because there is consensus overhead to resolve these forks, and also because when your UI is like, on this block and tells you you have some transaction in there, it's a little bit annoying when you reorg over to this one. Now, none of that is the end of the world. It's all normal blockchain stuff. But nonetheless, we want to kind of understand what kinds of forks there are and be able to predict what kind of forks might exist in our network based on the code changes that we make. So like I said, we made 2 different kind of forks earlier, and so we're going to see how they might play out here. So our goals are basically to look at all these different kinds of forks and then try to categorize them into some different boxes so that we have intuitions when we're going to upgrade our network about what precautions we might need to take, or whether we'll expect to see a long-lasting persistent fork like they did with Bitcoin Cash, for example. Oh yeah, so like I said with Babe, and with POW, not all forks are like really consensus level forks. Some of them are just these transient forks that can arise from time to time. So let's look at this taxonomy of fork types here. So I've got all forks, and I've sort of broken them into transitory forks and into consensus forks. And then under consensus forks, there's quite a bit more structure. And so I'll maybe let it just soak in for a second, but don't feel like you need to absorb this all right now, and then we'll move on and you'll never see it again, because the rest of this thing is pretty much like diving into the different pieces of this taxonomy. We're just taking our first overview look at it right now. Yeah, and I'll bring the mic to you. Oh, there it is. Can you pass that back? Go ahead.
Hi. So when there are forks, the chain is broken. I mean, it is how does it know which one it decides to? What is the chain?
You're saying how do you decide which one's the real chain?
Now there is a fork. So are both valids?
Right. So we're assuming they're both valid at this point. If we already talked previously about how maybe we rule some of these out because of state machine reasons. So at this point, we're assuming that they're all valid. And so the answer right now is that we don't know. Well, okay. The answer in general is that you use your fork choice heuristic. For example, the longest chain rule, okay? If your fork choice heuristic is something like whichever chain has the most blocks signed by Alice, and this is signed by Alice, and this is signed by Bob, then this is the best one. If our fork choice rule is longest chain rule, we don't know yet. We got a tie, and we have to wait until one chain grows, and then we can resolve it. Great question. So the general answer is there's a thing called a fork choice heuristic, and then if you tell me a specific heuristic, then we can answer concretely, this one's better or that one's better. Carla.
And what happens if it doesn't grow? If this still doesn't impact the
like if there's a tie, you mean? Like if I'm doing... Oh, sorry.
If that Alice's doesn't grow and the other one grows, impact the integrity of Alice's...
So you're saying if our fork choice heuristic is that we want to select whichever chain has the most blocks signed by Alice, okay, and then let's say it doesn't really matter what these ones are because they're in both chains.
Yeah.
And then let's say we have like Alice and Bob, and then let's say another block comes over here that's by Charlie. This is still our best chain. It has more Alice blocks. right? It has one more Alice block than this chain did. Now, I want to be clear, like most blocks signed by Alice is not really a good real world fork choice heuristic. That's like kind of gives Alice a lot of advantage, for example. Yeah.
And so,
I'll get you in a sec, but let me get this guy.
So, so we need to wait longer, right? So even the next one is the lower one with the longest chain.
If we're playing longest chain, then we have to wait longer. If we're playing most blocks with Alice, and this is an Alice block and this isn't, we already know. No need to wait.
But the longest chain, for example, there is the next one that.
Okay, so we've got like an Alice block, a Bob block, and a Charlie block, right?
And then it might happen that then later there are two more at the top. So we cannot throw it away yet, right?
Oh, no, don't throw it away. That's right. You don't throw it away yet. Yeah. It's the fork choice heuristic isn't saying like, this is the answer for now and forever, amen, throw the rest of it away. It's saying, this is what I think is best for now, and I might change my mind later. And you could imagine like, let's say we're doing longest chain rule and we get one here. Okay, top's best. And then we get two down here. Okay, bottom's best. And two more up here. Okay, top's best. Now, you want to tend to pick a consensus rule where those kinds of like long-lasting, constantly mind-changing situations are rare or are kind of like unstable so that they tend to stabilize and resolve eventually. And with proof of work and longest chain rule, you have that because as soon as a chain gets longer, everybody's incentivized to mine on that one. I don't want to be wasting my electricity mining on a chain that's already not canonical and probably never will be. I want to mine on the one that's already longest in hopes that I can get some blocks in there. Yeah, you were next.
And what happens with the data with the chains that are not chosen?
Yeah, when they get orphaned off, I mean, so those transactions are no longer part of our canonical history. Like we did this the other day, right? Alice got up, then she brushed her teeth, then she went to work, but over here she went to the playground. And if this is our real chain, she never went to work. That's not in the history. That's not our story. This is our shared story.
So the ones that are not valid, it's because they are not legit.
It's not because there's anything wrong with the transactions themselves. Like they could be valid in and of themselves. It's just that they're not in the history that we're choosing.
But something I don't understand. Then if they are valid, then it happens. The transaction happens or not happen. The one that from the chains that are not valid.
Okay. Are you into like Rick and Morty or the movie like Everything Everywhere All at Once where there's like multiple universes?
I love Rick and Morty.
Perfect. This is what's happening over here. Like in one universe, Rick abandons his family in Beth, and then in a different universe, like he stays home and he's a good dad. Which one happened? They both happened. There's no objective way to say which happened. You as a blockchain node follow your fork choice heuristic to say, this is the universe that I believe is real. In my universe, Rick stayed home with his family. Or this is my universe where he went off to be a space adventurer or whatever.
But then it could be a universe that I have some money and in the other universe I don't have any.
That's right. That's right. Maybe up here you mined this block and got a 50 Bitcoin reward. Down here I mined this one and you don't have your 50 Bitcoins. That's right. It's not that either one of them is more objectively correct. It's that we have a consensus algorithm that's eventually helping us agree on the real one. And I'll say most normal transactions can end up on both sides of the fork. So let's say like I just send some normal boring transaction, like I send you 2 coins or whatever, okay? I send it out to the mempool around the same time, 2 nodes author a block. Most likely my transaction's in both of these, okay? So it's not always the case that like, oh, I really want this one or else my transaction doesn't count and I'm effed forever. It's like, oh, it's down here too. Or even if it's not down here, maybe my transaction's here but not down here, and then this becomes the real chain. I mean, my transaction most likely can also make it into a future block on this chain, as long as I haven't already spent the same money somewhere else.
Thank you.
Yeah, you're welcome. Great questions.
Being an authoring node, if I'm following the longest chain rule and I see such situation, then should I wait or should I mine on both?
Oh no, definitely don't mine on both. Or people that typically don't mine on both, you typically mine on whichever one you see first, because as soon as you see it, look, you're not going to see them both at the same time, right? At some point, this one's hidden and you can only see this one, and you're like, oh, I just have like some linear chain, let me mine on it. Then some other block comes, you're not gonna like stop the mining process that you've made. You're like, man, I'm committed to this one. Let me keep mining on it and hope that I can like get a block and make this one that I've already kind of sunk some effort into be the longest one.
Thank you.
But the other thing I'll point out is that like, that is really up to you as a node. There isn't like The reason you do that is because it's the best strategy, not because the protocol says you have to. Like if you want to split your power, you can. I mean, if you want to, you can mine somewhere really silly like back here. You know, I'm just saying like the best strategy is typically longest chain. Okay, this is going to be like the last one, then I'll move on and we'll get some more in a little bit. Man, also new seat. I almost thought you weren't in class today.
Yeah, I was seeing like a Chinese movie late last night and I thought it was really good. It was the third version of Kingdom, and then coffee is not helping.
Okay.
So I did get you on the previous example of Alice's all thing, but then I thought I can't explain it, so I will explain it after the class. The reason I'm asking a question here is, what would be the typical flow of releasing the source code on the blockchains, the upgradation flow? Let's say if I'm a bad actor and I make the complexity on my node very, very simple, then I will always have more nodes processed and more transactions. So
yeah, so you're describing creating, okay, so I had this game matrix yesterday where we talked about mining honestly or mining dishonestly, and then we talked about how that was a little bit subjective. So you're describing a scenario where you decide to change the protocol, maybe to make the difficulty really low or do something else that allows you to mine a lot of blocks. If you have a large coalition of people who like that idea and do it with you, then you're creating the Bitcoin Cash fork or whatever fork. If you're doing it alone, then it's more like we're seeing you as just mining dishonestly and throwing your blocks away.
I just was saying mathematically, in this case, it would not mean that I would have to have the super majority or anything, because I am satisfying the longest chain rule. That means I have, let's say everybody else has 2 and I have 100.
Yeah.
So my
that's right. So you're sitting there in your own worldview where you say like, oh, I consider these particular kinds of blocks valid, and look at me with my long 100-block chain, and everyone looks at you and says, yeah, you're doing your own thing. Here's the main network. It has 2 blocks and a whole world worth of economic value behind it. You know, so you're like, you're describing creating a fork, and then what distinguishes it between like a serious community split versus some dude doing his thing is just how many people go with you. Okay, I'm gonna move on and let that sink in a little bit. So the first kind is the transitory forks. I think we've pretty much talked through those already. Those are the ones that are not because we've like changed our node code or something. Those are the ones because 2 Babe authors had a low enough VRF, or because 2 people solved the proof of work around the same time. I think I'm not probably gonna say anything else about those. Let's go on to the consensus forks now. These, I would say, are the sort of like more interesting ones, and the ones that get at the questions you guys were asking about, like what if people don't update their nodes, or what if only some people update their nodes? So usually when you hear about these kinds of consensus forks, they come in a lot of different flavors: hard forks, soft forks, and there's a lot of people who kind of aren't 100% clear on the terms and just throw out hard fork because it sounds hardcore, or throw out soft fork because they think it won't be that disruptive to the network. And sometimes those are sort of similar, but these things actually do have precise definitions, and I'm following the definitions from the MIT's, what was that thing called, like digital something initiative. They have like a taxonomy of blockchain stuff, and that's what I'm following here. So let's dive into them. I want to introduce this concept of the validity set. And so I've sort of alluded to it many times while we were still hacking away. And the validity set is basically like the set of all data blobs. If you just imagine a bunch of random bits, the validity set is all of those data blobs that when you tried to decode it as a block, you would say, hey, this is a valid block, okay? So if you think about monkeys typing at typewriters, they're coming up with all these random strings. Some subset of those random strings are J.K. Rowling novels, right? Not all of them. A whole bunch of them are not any kind of novel, and some subset are, we would call them like valid novels. And we're gonna do the same thing here. I'm using like a Bitcoin block, for example. And the reason that I have this up here is because I wanted to make the point that there are constraints on each of these fields, or at least most of them. So for example, like we know about this one, the parent block needs to actually match the hash of whatever the previous block was. The Merkle root needs to actually be the root that you get when you build the Merkle tree out of all the transactions and calculate it all the way up to the root. And there's a whole bunch of other ones here. You know, if this is POW, we need the threshold, the hash to be low enough, and et cetera. And so these are the kinds of rules that determine whether some arbitrary piece of data is in the validity set or not. If it decodes to a block that meets this properties, we call it valid. We say it's in the validity set. And if it decodes to bogus, or if it decodes to a block that doesn't meet these properties, then we say that it's not in the validity set. So, I mean, if we're talking about Bitcoin blocks, obviously the validity set is huge, right? It's like, I mean, millions or billions or like, I don't even know. We'd have to think about it, but definitely bigger than 3. But like for the sake of visualizing this, I'm just gonna say like, here's our validity set. It has like 3 different blocks that we would consider valid, A, B, and C. And then to picture all of it, these are like extra blocks that aren't valid because maybe the proof of work isn't satisfied or the parent hash doesn't line up. Or you can think of these as random strings that monkeys typed that didn't happen to turn into like novels or poems or something that we would recognize. The things that aren't in the validity set. And so I just called that the universal set. It's like, you know, the set of everything you can imagine. Okay, so let's do this example. Imagine this is Bitcoin, and here we see a few blocks from it. And the numbers at the top are the hashes, or like the couple initial characters, the hashes. And imagine that all the Bitcoin nodes suddenly decide that they really dislike when the first digit of the hash is odd. They just, for whatever reason, they hate it when it starts with an odd number, and they only want to accept blocks with even hashes. So which of those are going to be like in the new, more restrictive validity set? Yeah, A and B, that's right. So we've taken our validity set and we've reduced the space of it. It used to be that all 3 of these kinds of blocks would be valid, and now we've reduced it down so that only fewer of them will be valid. So we've done 2 forks in our blockchain network. Which one of our forks is this kind of fork? Is this when we added SHA-3 and Ketchak, or is this when we've removed MD5? When we removed MD5, yeah, it almost maps perfectly, actually, if you think of these as like MD blocks, SHA blocks, and Ketchak blocks. So whatever kind of fork this is the kind of fork that we had when we removed MD5. Go ahead.
What?
What?
What? Yeah.
Oh, what? That was your question? Oh, yeah. Okay, who wants to answer it? Anybody want to say that in their own words?
I think we were confused with the change, and then we also thought that the MD5 was the FBI or MD3 or something. We don't use it anymore because it's...
Yeah, okay. So I'm simultaneously talking through 2 examples that may have conflated it. So the one that's actually on the slide, we're saying that in the old blockchain rules, like when we first launched the thing, we were just allowing any old block, it doesn't matter what its hash is. And then at some point, we changed our mind. We said we're going to be more restrictive. Forget about the odd number starting ones. Let's only consider these even number starting ones valid. And then separately, I made the analogy to what we did in class, where we had 3 different types of POW seals. And then we said that MD5 is no longer valid. We're now reducing the validity set to only contain SHA and Ketchak. So there's millions of other examples too, right? That's 2 that we've looked through. You could think about like decreasing the block size, or you could think about like maybe in the old days we were kind of libertarians and we allowed all valid transactions, but maybe now we're more I don't even know what the right way to say it is, totalitarians or something, and we want to like censor terrorists, or like I don't even know. So there's all kinds of examples you could use. Okay, so here's some like slightly more mathy notation that means the same thing. We've basically got O for the old set, validity set, and N for the new validity set, and then the symbol there that means like subset. So this thing that we're talking about is a soft fork. When you decrease the space of valid blocks, that is called a soft fork. When there's things that used to be legal that are no longer legal, that's a soft fork. Yeah, get a mic.
In your previous slide, it would not always be a subset, right? For example, in your example, something that is not valid before becomes valid.
So that's the next type of fork that I'm not talking about yet.
Okay. Yep. So soft fork is always subset.
Yeah.
Okay,
what you described is a hard fork, but we'll get to that. You're right. There's both kinds. Yep. So I just want to caveat, like in my mind, it's like always very clear to me whether we're making the validity set bigger or not. But for some reason, it's extremely hard for me to remember which one's called soft and which one's called hard. So like, take it with a grain of salt if I say it wrong. I'm like, I'm going to try really hard. I actually practiced a lot to try to not mess it up. I don't think I've messed it up yet. So the soft forks are when the space of valid blocks gets smaller. So soft forks are sometimes called backwards compatible. And by making the consensus rules more strict, yeah, like I said, the validity set gets smaller. And not every, and often none, of the blocks produced under the old rules will get accepted by the new nodes, okay? But sometimes people would think that never can a block produced by the old rules get accepted by the new nodes. But that's not actually the case. We could have been having a block that a node that still accepted all three of our hash seals, right? Our MD5, our SHA-3, and our Ketchak. And it thinks all of them are valid. It happens to mine a SHA-3 block. That would still be accepted by the new rules because that's one that was just in this part of the validity set to begin with. So it's not the case that every single thing that the unupgraded old nodes want to do is considered invalid. Some of the stuff is still valid, but some of it's not. So if an old node authors a block that's out in this space, the other old nodes will still accept it, but any new node, any node that's upgraded, will start to reject that block. And so here's some examples. If you wanted to decrease the block size, we're no longer going to allow large blocks. Now they have to all be under 1 megabyte. That would be an example of a soft fork. Okay, so now let's start to get to the question that you two were both asking about, which is, when some of the nodes upgrade and some of the nodes don't, do we have this kind of thing where we have a long-lasting, persistent network split, or is it the case that we kind of follow the majority hash rate? So this is a soft fork with less than 50% of the hash rate. That means that less than 50% of the nodes are in the new set, and more than 50% of the old nodes are still out here in the old set, unupgraded, being more accepting more blocks. A bigger validity space. So this block is a new style block, right? We know that it's definitely inside of this smaller, newer validity set. And it's in both chains. So how is it that this new block is getting accepted by the chain that the old nodes are on? What's up with that? Why are the old nodes accepting a new block? Yeah, bingo. N stuff was always accepted. Look, the N is inside of the old validity set, so they'll continue to be accepted. Now, maybe I'm the only guy that's in the new set here. It's just me on my island with way less than 50% hash rate, and somebody from the old rules comes along and authors this block. What do I do with it? I reject it. I'm on the new rules. I'm never going to accept this. I'm never going to move into one that to a block that's strictly in the old rules. And so consequently, I end up mining my own chain down here. Me and my couple buddies who are doing our little less than 50% hash power thing. And meanwhile, the rest of the network hash power is up here on the old chain, mining along, and growing faster than us because they have more than 50% of the hash power. So if this chain's longer, why am I not reorging back up to this chain? Yeah, these blocks aren't valid. I don't consider these valid. I only consider it valid if they have N's in it, because I'm, doing the upgrade thing here. Okay. Yeah. Oh, they absolutely can have some N's. The next one could be an N, absolutely. But that's not going to make me reorg either, just because there's one N, because there's still these other old ones. Yeah, actually, this figure would have been better if I had an N right here, huh? Because then that shows that. That's a great observation. This can still be mixed. This can still be N's and these everything kind of blocks. Very good observation. So to answer your guys' question about what if less than 50% of the hash power tries to do this thing, if it's a soft fork where you're getting more restrictive, you're going to have your own fork. You don't need anyone else to come with you. You can just go off on your own fork and do that. Now let's look at the other case where the soft fork has more than 50% of the hash power. So this time it's not just me and maybe a couple friends here, it's the vast majority of the community. We're all trying to do this fork thing, okay? So chain starts out the same, everybody accepts all of this stuff, the N's have always been valid. And then, again, over here, maybe I author this new block, I accept that. And then some old node authors this block. Okay? I obviously don't accept this one, but I only see this as valid. But from the perspective of an old node, an unupgraded node, What it sees is two perfectly valid forks, and we just need to wait until the fork choice heuristic resolves it. Okay, I'm going to pause. Go ahead.
Okay, so like I'm starting to see that like lobbying and like having conversations and like arguments online about like what to do becomes really important.
Yeah, please
for-
come mine my chain. We need more hash power. It's way
Yes.
better.
Yeah. So then I have a question. What's when that kind of happens and you come to these kind of decision points in the Polkadot ecosystem? I'm just not very familiar, like on the Polkadot ecosystem. How do you guys deal with that, and how do you manage for that? And then, like, are you good at gauging like this is actually what the community wants, and this is the infrastructure we use to do that? And
Yeah, so your question is kind of got Polkadot specific at the end, and I'll say that like all of this blockchain stuff, Polkadot's a blockchain, right? So in some sense, this is all relevant to it, just like it is to every blockchain. But Polkadot is a little bit of a special blockchain because it has this feature called forkless upgrades. Now, I'm not going to tell you about that now, but Kian will tell you about that for sure. So in the Polkadot ecosystem, most of the time, it doesn't come down to arm wrestling over hash power. In the Polkadot ecosystem, there's like a proposal on chain, and then you vote for it through governance, and it either passes or it doesn't.
so you save time. A lot of time.
Yeah, exactly. And not only time, like, so far I've described this as like a intentional political or philosophical like rift. Sometimes when we go to upgrade the nodes, it's not that there's any political opposition. It's just that like that miner's on vacation and that miner's lazy and they just didn't update their code, and you get, even when no one wants it, you can have nasty forking. And so like forkless upgrades are really good, especially for that. Your question though about like how to communicate and do the politics is really, really, really like on point, and I would encourage you to read some of the like flame wars from Bitcoin talk around 2017 when they were trying to scale or not scale. Yeah.
And what happened if initially it's below 50% and then more people upgrade and then it becomes...
Yeah, that's extremely common. So, whoa, that's not where I meant to go. Because a lot of times what'll happen is like people want to upgrade eventually, but they just don't get around to it right away. So it starts off with like less than 50%, and like all the new nodes are up here and everything. So let's say though that like maybe my node was like syncing this chain, and then eventually I upgrade to the new roles. So for my node, there's nothing magical about this point, right? This is the point where the node upgraded. So if I upgrade my node up here, then I'm going to do this same thing on my own little fork over here. And everyone who upgrades is going to do that same little thing until eventually there's more than 50% hash power. And then everybody starts And then everybody starts reorging to the new chain. Yeah, Marcus.
More or less. This is more or less on the topic of forks in general. I don't know if you'll bring it up later on or anything else like that, but what exactly was the whole, was it the DAO for Ethereum? There was a whole fork situation with that.
Yeah.
What was that exactly? Was it a hard or soft fork, and why did it happen?
Oh, okay. Was it a hard or a soft fork? Let's work our way into that. So what happened was there was a smart contract called the DAO, and it had some code in it, and someone sent a transaction, and the computers faithfully executed that code, and it had some side effects. And those side effects were not what was expected by the developers. They said, this is a bug, our contract was clearly bugged, you're making off with all the money, it's very clear that's not what the contract was supposed to do. Other people took the viewpoint that we're using smart contracts, the whole point is that the code is law. If I wanted a squishy thing where we could say that's not what we meant, I would have signed a paper contract and filed it with some court or lawyer or something like that. And so there was a little bit of a political discussion here about what you wanted to do. Okay, now that I've talked about it, I know that that was a soft fork, and here's how I know. So what they did was, they called it the hard fork, didn't they? Because it was a rollback. Yeah, that's right. That's true. Okay. So this is a little bit, it's a little more complicated when you want to go back and undo history as opposed to just change something going forward. So that's a complicated one. Hopefully that answered the question about the background at least. So on ETC, Ethereum Classic, that's the political camp that says code is law. When you write a contract, the code is what it is, whether it's what your human brain intended or not. And then the main Ethereum chain are the ones who said, this thing is new. We don't want to F up our one chance at a global economic system. We're undoing that one. And then there were, interestingly though, people said like, that's going to set a precedent. And only a few years later, there was the Parity wallet hacks where a whole bunch of ETH got locked up in there too. And some people, again, wanted to fork, like, hey, help us get our money out of this wallet. And that time they didn't. So, politics can change, or maybe it's just the case that like the DAO hack was huge and the Parity wallet hacks were, not tiny, but compared to the DAO, pretty small. So, okay.
So let's say it started with less than 50%, and some nodes actually thinks that the upper one is right, and then it becomes actually previous slide. The upper one is right.
Previous slide?
Yeah.
Sorry, previous slide.
And then it keeps on building because it's the longest chain.
Yeah.
It thinks it's valid. And then one day I upgrade.
Yeah.
And then I actually saw the rule that, since after whatever block 3000, I should not accept the O anymore. Does it mean that I always think this is true?
Okay, so then, here's the thing though. If the fork encodes a line, like here's where the line is, and your node like starts to sync beyond that and then blindly upgrades, now it's in a little bit of an inconsistent state, right? Because you already synced these blocks into your database, then you went and swapped back code that retroactively invalidates them. So if you're gonna do that, like if a block specific hard fork fork happens and you don't upgrade till later, then you're going to want to at least roll back these blocks, or some people just resync from scratch.
So basically, the block that I thought is good, indeed, then I said, it's invalid.
Well, yeah, that's exactly what it means to upgrade your node, right? To change your mind about what the protocol rules are and decide, I'm an N guy now, I'm a new validity set guy, these are no longer valid. Okay, I want to move on to get through hard forks and stuff. Still. So, hidden forks. Yeah, right. Okay, so a hidden fork, I'm just going to do this real quick. A hidden fork is a special kind of soft fork. It's like an edge case of soft forks. And what happens when you do a hidden fork, it basically is the case that, here, let me go back to my Venn diagram. It's the case that there was an old validity set, and now we're making a smaller new validity set. That's what it takes to be a soft fork. The reason we call it hidden is because nowhere in the entire history of the chain have we ever had one of these kinds of transactions. So even though the old protocol rules technically allowed them, they never showed up on chain. And so when we do the fork, you can't really see it in the history of the chain. It just seems like the rules were always this reduced set here. And so the time when this happens is when someone's reading your blockchain code and says, oh crap, there's a bug here. We need to fix it before anyone exploits it. So maybe the old rules allowed this particular kind of bugged transaction that would let you steal money. No one noticed yet and made that transaction. And now we're just going to shrink the set before it ever becomes an issue. So hidden forks are basically soft forks without any drama attached. Let's throw a mic back here. Oh, you got it.
So in the way we did forking right now, there's two different forks that we did, right? We did git pull and then, so in that case, in this manner of forking where people do git pull and then they build again and run, the only way to know that there was a fork happened and there was a thing changed is through the code, if you mentioned in a comment or something, or maybe the git version history, which is on
like
a
for
centralized
this
system.
hidden fork, you mean?
The way we did it, right? In the practically.
In our chain, you can see it just by looking at the history of the chain, because you can see like, or at least with high probability, you would know something's up because you would be like, there's this beginning section with nothing but red blocks. And then there's this next section where there's, like red, I forget the colors, like red, purple, and blue blocks. And then there's this section where it's only purple and blue blocks. And maybe you can make an argument that like they were all valid all the time and just by like sheer coincidence they lined up this way. But like basically you can see it there, Or like if you look at the history of the Bitcoin Cash chain, for a long time, it was all 1 megabyte blocks, 1 megabyte blocks, and then all of a sudden, it's all 8 megabyte blocks.
Yeah, so
it's like, okay, something must have happened there.
Yeah, so if a third person comes who got the latest code, and let's say they deleted .git folder, or there's no comments we mentioned, so the only way they can infer these changes that happened in the history is through manually tracking down on the events and tracking down the data.
In old school traditional blockchains, that's right. And Polkadot's forkless upgrades make it a little nicer because then you can explicitly see it.
Those will be in form of transactions to the blockchain itself, right?
Yep. Okay, sounds like you get it.
Cool.
Okay, let's go on to hard forks here. So a hard fork is the other kind of thing that we did, and it's the exact opposite. It's when the space of valid blocks gets bigger. So this is what we did when we went from only MD5 to also allowing MD5, SHA-3, and Ketchak. So that's the first kind of fork that we did. So we make the rules less restrictive and the space of valid blocks bigger. Every block producer under the old rules will get every block produced under the old rules will get accepted by the new rules as well. So the examples are kind of like the opposite here, right? Like this is the Bitcoin Cash thing. If we want to make the blocks bigger, that's a hard fork. Now the footnote here is that eventually the Bitcoin Cash people realized like, oh, hard forks are a little bit not ideal in some ways. We better do a different kind, and we'll explain that later. But if you think about the simple Bitcoin Cash fork where you do nothing other than increase the block size, that's purely a hard fork. Purely increases the space of valid blocks. And so let's see what happens when we have a partial upgrade this time. So here, someone comes off and authors a new block, but this time the new stuff is not accepted by the old nodes. It's rejected by the old nodes. Before, N was on the inside. New stuff was always valid for everybody, but not anymore. Now a block that's mined specifically with a new thing, so like with SHA-3 or Ketchak, it's going to be rejected by the nodes who still have the old rules. And this can happen multiple times, you know, like imagine I'm a new node, I author this block, then I see this one come in, still valid, right? It's still inside the bigger set. So I think like, okay, there's just a fork, let's wait for the fork choice rule. But I have less than 50% hash rate, so in general, the other chain's gonna grow faster. And when this block comes out, I'm gonna reorg to this chain. Because even though I think the N block was valid in and of itself, I now see another longer chain that's also valid. So I keep mining, and hey, I got a block again. But then the same thing happens. Anytime I get a block, I'm eventually going to have to orphan it off because the other chain's always going to grow faster because it's the muscular chain with more than 50% of the hash power. This is the exact opposite result of what we saw with soft forks. And so then here's the deal if you have a hard fork with more than 50% hash power. This time, me and my friends doing the new thing, allowing these new proof of work seals, we have more mining power. So even though we consider these blocks valid, we're never going to reorg up there because we have our longer chain down here, okay? So does it work the other way? Do the people who authored this block, are they going to reorg down to our end chain down here? Would a node that's using the old rules reorg to our longer chain down here? No, you're shaking no, and that's exactly right. Because the old rule people, sure, they consider some of our stuff valid, the part that's in here, but there's a whole bunch that they don't consider valid. So let's just do a little summary here. On the left, we have soft forks, and on the right, we have hard forks. On the top, we have minority hash rate, and on the bottom, we have majority hash rate. And so you can see, again, they're exact opposite. With soft forks, if you're looking to get a permanent chain split, you need less than 50% hash rate. But on hard forks, if you're looking for a permanent chain split, you need more than 50% hash rate. Yeah, let's get the mic back there.
So what would happen if the network had so many hard forks such that no chain had more than 50%?
Oh, that's an interesting idea. So yeah, I mean, my validity set diagrams have always been new and old, right? But you're saying, what if there's like Joshy's validity set and Alice's validity set and Bob's validity set? That's a great question. I'm not ready to think through that yet. But if you draw your Venn diagram of the validity sets and draw some chains and write, you know, this one follows the Joshy rules or whatever, I think you would be able to come up with the answer to that. Yeah, let's chuck that mic up here. Nice, guys.
So basically, you can't do a hard fork with less than, if you don't have the majority of the hash power.
Yeah,
that's why
right.
they're called hard forks. Or
yeah, so that's exactly right. And if you go back to this slide that I had here, where I said Bitcoin Cash was basically a hard fork at first. Well, the Bitcoin Cash people were political people. They believed for philosophical and political reasons that the block size should be bigger. And so when they did their hard fork, I mean, at first I think there was a genuine like hash war. We didn't know what was going to happen. Eventually it became pretty clear that the original BTC chain had the majority hash rate. So the Bitcoin Cash folks were stuck in this situation. They kept reorging to the small block only chain. And so at that point, the Bitcoin Cash community said like, okay, this clearly isn't working. Let's do our fork differently so that we can have some kind of like long lasting fork. Because we not only like want to try to make this thing bigger, we want to insist on it. We don't want to be stuck in this small block world. So let's look at what they did. They did a full fork. And I think that it's also possible if these are partly overlapping. What's important is that there's some space that's solely in the new rules and some space that's solely in the old rows. Yeah, in the back, Mauricio.
Yep. My question is on the soft fork with larger 50% hash power and the hard fork with the same parameters. So in the soft fork, although
Sorry, hold on. Which
yeah.
one were you talking about? This one?
No, down. The
This
soft
one.
fork,
Soft fork with more than 50%.
And the hard fork with more than 50%
the bottom
hash
row.
power.
Bottom row in general.
Yes, exactly. Yeah, those two. So one thing is in the hard fork, the smaller chain the down chain can't actually accept the new blocks which are produced in the upper chain because the rules are completely different and they have minority hash power, so they can't be any reorgs in those two forks. But
these people do think that these blocks are valid. They're not saying they're invalid. They're just not selecting them because there's a longer chain.
Okay, and also the top ones the top ones don't regard the bottom chain as valid also, right?
So these guys do not consider the bottom chain valid. Yeah, that's
okay.
That's why they're not reorging to it. If they thought this was valid, they would reorg to it because it's longer.
But also, okay, now in the soft fork part.
Yeah.
With the large hash power. So now the newer chains has more hash power, so the chain will be longer. But also the minority are using the older rule. But one thing in the soft fork is the N is inside O, right?
Yes, exactly.
So the older people kind of know, okay, the N are correct and we are also correct, right?
Yeah.
We can reorg, but then our chain won't have continuous history.
Yeah, exactly. And this is like what kind of people don't like about soft forks sometimes, because some people like about blockchain this idea that if I want to keep the network running the way it always has been, all I have to do is run my own node. Everybody else can change, but I have the power to stay in my world. But that's actually not always true here, and specifically in this case, because you can see me trying to stay in my world here, but I always get reorged into the longer chain. Vitalik had a post like from 2017 or 18 called like soft forks are more coercive or something that was a little bit of a mind blow at the time, but basically is pointing out these things now that are kind of better understood. Yeah, I mean, it seems like you got it, man. You talked through it exactly right, Boda. And then we got to move on.
So does that mean that we can have two long-lasting forks, like for really long time, in case of soft fork with less than 50 and hard fork with more than 50?
Yeah, and not just can, you will.
Okay, and they're there, like they.
That's right. Yep, they're there until one side changes their mind or stops mining or whatever. Yep, that's exactly right.
Thank you.
Okay, so let's keep rolling. So we looked a little bit at the full forks. And so by changing the consensus rules, the set can become disjoint or only partially overlapping. And then most blocks produced under one rule set aren't accepted under the others. And so this is what you do when you know that you're not going to get your way just doing a hard or soft fork, whichever one comes more naturally. You want to do this. So pretty much anytime you're doing a fork for a like philosophical or political reason, you're going to want to do this. It's honestly better for both sides of the fork that way, because you each get to have your chain and have your hash rate and everything, and neither side is getting compelled to stay with the other side. So if it's just a matter of like people not upgrading yet, sure, do your hard and soft fork, try to get everybody to upgrade. But if it's a contentious or political debate and the communities are ready to just be split, don't just do a hard or soft fork, because someone's going to keep getting yanked over to the other side. You have to do a full fork. So here's a couple of examples. Okay, right, and then just to visualize the point that I made, regardless of whether you have majority or minority hash rate, once you've changed the rules in this way, then you always get a long-lasting chain split. Okay, yep, one question.
I'm very bad at cricket, okay? So what I wanted to ask is, you guys are developing the UTXO model with Andrew, and Substrate supports the account model. So is the plan, let's say, and I'm not, you don't have to answer that, but let's say if the plan was to include it and have two options in Substrate, how would that
So
roll
this
out?
is kind of a Substrate question. Substrate is actually not fixed to being the accounts model. It's just the case that most Substrate chains are the accounts model. So you can also have a Substrate UTXO
Like
model. Yeah.
Polkadot then?
Oh no, Polkadot is accounts. Polkadot's accounts based.
So they can't have both.
I mean,
Because you're giving me examples
I've never
of
heard of
hash.
something like that, but it's kind of an interesting idea where maybe you have like half accounts and half UTXOs.
Because you know MD5 and then SHA1 and they all are all separate. So I thought maybe why not have both of like UTXO and
Yeah, it's an interesting idea. All right, let's let Chris get a question.
So when you're doing a full fork, it doesn't really matter how much hash power you have, right?
Yeah, that's exactly right. I mean, the only sense in which it matters is the sense in which, like, eventually the greater world is probably going to consider one side or the other, like, real. You know, in the sense that we've pretty much decided that the original Bitcoin is real and that the forked ETH is real. Okay, this is pretty much like a single slide that summarizes everything that was in the talk. So I'd say just open this up tonight and sleep with your head on the computer, and it should all be in there.
why didn't we start with this one?
Yeah. Oh, yeah. Here it is. Okay, you guys got it. Let's go back to. Yeah. Okay. Question.
On the soft fork with less than 50%, you mentioned that it will be two chains in parallel, right? So basically,
yes.
right? And then
Yep.
eventually there'll be more and more people with the upgrade.
Assuming it's not some political thing and they're like getting around to upgrading. Yeah, that's right.
So meaning that the top one, when more and more people upgrade, may be starting to have more N. So eventually, will the lower one actually take the top one because it's the longest chain as the
Yeah,
right one?
exactly right. And you're actually getting at something else that's interesting, which is that like if people take a day to upgrade their nodes, maybe this will sort of like get sorted out pretty quick. But if they take a month or a year to upgrade their nodes to get to this point where there's more than 50% hash power, like the longer it takes to get there, the more of a head start you've got over here and the more of a deficit you have to dig out of before this thing.
So in that scenario, for example, I'm the one that upgraded first, right?
Yeah.
Initially, I don't agree with the top one because it doesn't have that. So I
Yeah,
only
that's right.
agree on the end, right?
Yeah.
So eventually, more and more people upgrade, then that becomes the longest.
Yeah.
Will I switch to the longest one, even though I didn't agree?
You're not upgraded, you're an old rules person. Yeah, you're gonna get reorged in. That's this
No,
scenario right
I'm
here.
actually a new rule person. So I'm the
Oh,
one.
I misunderstood that.
I'm
Okay,
the
go ahead.
one that on the first diagram. Yes. So
Yeah.
I'm the shorter one, right?
Yeah.
And the upper one get longer, but then more and more people upgrade, and then it will eventually become.
And yours starts to catch, and they're both growing, and as more and more people upgrade, yours starts to grow faster and catch up. And eventually, it overtakes. And
But-
once
but-
it overtakes, then the old folks will reorg down to the new rules.
But what I think saying is that the top one.
Yeah.
So we'll get the N eventually added, right? Because I actually, for example, more than half of them actually.
You're never going to
use-
get an N block put up here.
No,
N, oh yeah, okay.
but then I upgrade, and then I actually thought the top one is right, and then I upgrade, and I also.
Okay. So I see what you're saying. Like, there's a subtlety we need to decide though. Was this a soft fork that was set to take effect at a specific block?
No threshold.
No,
So
okay.
basic.
Okay. So tell me your scenario. No threshold. You
So
just
the
upgrade your
scenario
nodes.
is that initially I think the top one is the valid one because I also agree O, right?
So then you fork off
And then I
another
fork.
different one.
Correct. And
Yeah, yeah, exactly.
and
Like,
then-
I mean, we can see that happening right here.
That will
talking
eventually
about
become
this.
the longest one, right?
Yeah.
And then the one that originally doesn't accept the top chain because they upgrade earlier,
Yeah.
will they eventually say, oh, the top chain is okay, even though I don't agree with the first few blocks because I upgrade first? But
No.
because-
They're never going to accept those ones, I guess. This has to happen at a threshold, right? Because otherwise they'd never accept these old ones. So you have to have a threshold for this kind of fork. It has to have some line. This is a really, really good question.